In this video, we will look into the how to find horizontal asymptote and vertical asymptote. And before we approach this problem, I always like to create an image for my students before we do anything algebraically. So let's say this is a graph paper, okay, and let's say we look based on what we have learned previously. I think we should have a good idea what a horizontal asymptote looks like and a vertical asymptote looks like. Okay, so and then we can sketch a hypothetical graph. So it's going to be something like this. Okay, or there are a lot of different variations, but I'm just going to go with this. Okay, we just need an example. Now, when based on this example, we have to build our understanding from this diagram, which is why do we have this dotted line, and are these graphs going to touch these dashed lines or dotted lines? Okay. Now, for horizontal asymptote, there will be no function value. So for vertical asymptote, there is no function value, okay, for that particular x value. Okay, so if you put in x into the function, nothing in return. It says undefined. And if you look at this, example, so you think about, okay, so is there any point where there will be an undefined undefined result, okay, for this function? Well, consider that this is a quadratic, this is a rational function, is a fraction. So it could become undefined if the denominator is equal to 0. So that's the reason why we will go ahead and say, okay, let's go ahead and factor it. Okay, let's go ahead and factor, and it's going to be plus 2 minus 1. Okay, so we factor this, and then we have x plus and x minus, and that it's going to be this is going to be this, and it's going to be x minus 1 over here. Okay, x minus 1 over here. So now there's nothing you can cancel out, and since if the denominator becomes 0, then the whole function will become undefined. That is the reason why we say, oh, go ahead and set the denominator equal to 0, because that is the scenario where we will have undefined values. So we say, okay, x plus 2, x minus 1, these two together, we set them equal to 0, and then, well, to multiply and get 0, that means we have two scenarios, two possibilities, which is each parenthesis could become 0. So we have two vertical asymptote here in this case. We have -2 and +1. And the next thing is, well, what about the horizontal asymptote? Well, the horizontal asymptote, it's really about when x is getting bigger and bigger, infinitely bigger, where the function is going to, okay? It has nothing to do with the idea of vertical asymptote. It does not include the meaning of not touching the horizontal asymptote. And this is the reason why sometimes when you graph or you see other functions, you might see a function that actually crosses the horizontal asymptote, and it's perfectly fine, because the meaning of horizontal asymptote is where it is going. And so what we would do is we will do this. Okay. Now there's another video that I made and to show you how to find limit as x approaches to infinity. So you can look at that video, and for short, we're just going to say, well, x is going to become an infinity, so x squared is really a huge number, so these doesn't matter. Okay, and so we have limit as x approaches to infinity of 2x squared over x squared, and you can further simplify this, and it just becomes limit as x approaches to infinity equals to of 2, so the limit is 2. So our horizontal asymptote is y equals to 2. Okay, So for more instruction on finding horizontal asymptote or limit as x approaches to infinity, click on the previous video so that you know how to find that.